So this is lecture 19 on selecting an indicator. So now we're just looking at actual problems. I'm not really going to do the problems with you. I'm just going to assume that you can probably do them if you've been following along well. We're supposed to select an indicator that will work with the following titrations. Um, okay, so in so these are problem six. This is problem 65 from Zumdahl. Um, you're titrating 100 mils of 0.2 molar acetic acid. It has a K of 1.8 times 10 to the minus fifth with 0.10 molar KOH. And so if you do the stoichiometry and you do the Rice, you'll find out that at 200 mils you get equivalence, and then you can calculate the pH at equivalence. So that's what you have to do to begin to do this problem. I'm just skipping that step. And so you would find out that at 200 mils there's equivalence, and then you plug that in and you calculate the pH. You get a pH of 8.79 for equivalence in this particular system. So once you've done that math and you figure out the pH at equivalence was 8.79, now you go to a chart that's on page 632 of Zumdahl, and you look at the pH range of color change for various indicators. And you would find that phenolphthalein changes color from pH of 8.1 to 10.0. It changes from clear to pink. And so, because this is in that range, this is a good indicator to choose. And you don't have to be too precise because of the steepness of that curve that I talked about in the last lecture. So once again, what you do is you find the pH at equivalence, and then you go to a chart, you select an indicator who's changing colors in that pH range that equivalence at. Okay, so now in problem 2, it says select an indicator that would work well for titrating. So once again, you're searching for that equivalence point, and you're going to identify it by the fact that this beaker is going to change color when you get to equivalence. So now you're titrating 100 mils of 0.1 molar H2NaH2. So this is a base. You've got base in your beaker now, and it's got a KB of 3.0 times 10 to the minus 6 with 0.20 molar HNO3. So now this is from problem 66. It's asking you to figure out which. So now 50 mils of this reaches equivalence with this, and you have a pH of 4.82 at equivalence. So now you go to your indicator chart and you're looking and you find that bromocresol green changes from yellow to blue, a pH range of 3.8 to 5.3. So that's a good indicator to choose for that. And now, finally, in 69, you're titrating 25 mils of 0.10 molar NH3 with 0.10 molar HCl. You'll find that if you do the math, that 25 mils of this is equivalence. And when you plug all that into your stoichiometry and Rice charts, you get that the pH is 5.28 at equivalence. Once again, you're going to pick bromocresol green. Because it's got a pH range of 3.8 to 5.3 that it changes color over. And this is within that range. And so these are the 3 indicators you pick for these. And they would work well at telling you when equivalence occurs. And once again, if your graph looks like this, you're just trying to find this mark right here. So you're trying to find that volume that you're adding. You want to know that because it's going to tell you the concentration of the chemical in the beaker through the math that you had to do this stuff to get those pHs in these problems. So thank you. I hope that helps.